Hey everybody, today we're looking at Law of Cosines, another application in our unit on trigonometry, analytic trigonometry, lesson 6. In our previous lesson, we used the law of sines to solve triangles given angle, angle side, side side angle, and angle side angle. Now today we're going to look at the law of cosines to solve triangles given that are specifically side angle side or side side side. When you're given the following triangle with sides A, B, C and angles alpha, beta, gamma, we can set up three equal ratios. These proportions are known as the law of cosines. The square of one side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. Now that's a mouthful of words. So here is that statement algebraically. When you have a side squared, it's equal to the square of the other two sides minus twice the product of those squares times the cosine of your angle. So whether you're looking for side A, B, or C, you can use this set of formulas. But if you're looking for an angle on a side, then you're going to use this set of formulas, which has been solved from here to isolate those terms. There's a couple of techniques for solving side triangles. This is important. You want to find the angle opposite the longest side first. That's really important, because we don't want to end up with anything that's not possible based off of our findings. And then after you found the angle opposite the longest side, you can use the law of cosines if you like, or you can continue to use law of cosines. But if you use law of sines, you can find any missing angle that way, and then the third angle. And then if you want to find you're given a side angle side triangle, the technique is going to be to find the side that's opposite the given angle. That'll be the only thing open to you at first. And then you can find the angle that's opposite the shorter of the two given sides. And then you can find that third angle. So we'll see how this plays out with our examples here. In example 1, we're given a side. So I can go ahead and create that triangle. If you would like, A, B is 7, C, we don't know. Little a is 13, B, and little c is 19. So we have side A is 13, side B is 7, and side C is 19. So given side, the first thing is to find the angle opposite the longer side first. So that would be angle C. This is our longest side. It's going to have the biggest angle. So in order to do that, we want to find the cosine. We want to find angle C. So we could do that by using the formula. The cosine of C is the b squared. So cosine of C is a squared, which is 13 squared, and b squared, which is 7 squared, and then minus c squared, which is 361, and we're going to divide it by 2 times 7 times 13. Okay, so we got, if we're looking for this angle, we're going to square this side, and then subtract the square of that side and double 2 times 7 and 13. So it's this side angle side area we're doing first. That means angle C can be found if we take the cosine inverse of, now I've done the math here, 169 and 49 and 361 is negative 143. and 2 times 7 times 13 is 182. So we're going to jump to the calculator and find the radian measure of that amount. So we want cosine inverse, and I need a fraction of negative 143 divided by 182. And that's the radian measure, 2.47. So I want to multiply that times 180 divided by pi. And that's going to give us our angle measurement. So we have an angle of 141.787. So angle C is about 141. I got the wrong pen. Angle C is about 141.787 degrees. We got that from this. That was 2.47. We had 2.47465. And we multiplied that by our conversion factor, 180 over pi. And that's how we knew we had about 141.787 degrees. Okay, so that's the first thing. Find the angle opposite the longest side first. Then the second thing we want to do is use the law of sines to find any other missing angle. So our second step, we can find the angle for A. So sine of A divided by 13 is equivalent to the sine, and I'm going to round this to 142. 142 over 19. So using my highlighter to find the sine of A, we need to multiply 13 times sine 142 divided by 19, and that'll give us the radian measure for angle A. So angle A, if I want the angle radian, it would be 13 times sine 142 divided by 19. And then you want to take that answer and convert it to degrees. And I'm going to get 24.91 degrees for angle A. So 24.91 degrees. And let's look what that looks like on our calculator. So again, we want the sine inverse. And our fraction is 13 times the sine of 142 degrees divided by 19, and that answer was 0.43, so we're going to multiply that by 180 divided by pi, and 24.91 degrees. So if we had 180 degrees and we found 141.76 and 24.91, that's going to leave us roughly 13.3 degrees for the missing angle. So angle B would be roughly 13.3 degrees. And you could round them to whole numbers or whatever amount you need to estimate. Okay, so that's example 1. Now example 2 is going to be two sides with an included angle. So we have different rules for that. And starting out here, if I call this 102 degrees, that's angle A. And then B is 5. C we don't know. Little a we don't know. Angle B we don't know. And little c is 3. So C is going to be our shortest angle. And the only thing open to us right now with this side angle side approach is to find side A. So using the formula for side A is the square root of B squared plus C squared minus 2 times B times C times the cosine of the included angle. Now here's a little word of caution. Do not add 25 and 9 and get 34 and then subtract from that. You need to do all of this at one time to make sure you're handling the order of operations correctly. Because this is what, 30? You can't say 34 minus 30 is 4 and then do 4 times cosine, because that will not be correct. So be sure you follow the order of operations. So I'm going to do the whole thing at one time. We got 25 plus 9 minus 2 times 5 times 3 times the cosine of 102 degrees. And we got 6.34 for the measure of side A. So side A, little side A, is about 6.34. And you can tell the longest side is opposite the longest angle. So now we want to find the angle opposite the shorter of the two given sides. That would be angle C. So our second step is to set up the proportion for the sine of C divided by 3 is equal to the sine of 102 divided by 6.34. So angle C is going to be sine inverse, and again, 3 times sine 102 divided by 634 gives us the sine. So writing that down, 3 times sine of 102 divided by 6.34, and whatever answer that is, we want to multiply it by 180 over pi to convert to our degree form. So once again, we want the sine inverse of 3 times the sine of 102 degrees divided by, whoop, that didn't work out right, did it? We need a fraction in there. 3 times the sine of 102 degrees divided by 6 34/100. So that number times 180 divided by pi would be 27.571 degrees. So that number was 0.481203. 0.481203. And now we know angle C is about 27.571 degrees. And then the third step would be to find angle B, and I'll leave that to you, but I believe that is 50.43 degrees. So once again, we've solved those missing pieces. Angle C is about 27.57 degrees, and angle B is about 50.43 degrees to get the missing pieces for the triangle. Here in example 3, we have an application. We have 2 airplanes that leave an airport at the same time on different runways. One plane, so if this is the airport, can make a picture as we go. One plane flies directly north at 420 miles an hour. The other airplane flies on a bearing of north 75 degrees toward east. So that would be off this way at 375 miles per hour. How far apart are the planes after 2 hours? So the distance would be, this is the first plane and the second plane. The distance would be this piece in here. And if we go for 2 hours, then 420, that rate times 2 hours means this first plane has gone 840 miles due north. And that this plane, which has gone 75 degrees east of north, it has gone 375 for 2 hours, so it's traveled 750 miles. We want to know that length right there between these two. What's the distance between? So this is a side angle side, and we can find that distance by doing 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine of 75. And then taking the square root of all of that. So let's go to our calculator for that. So we have document. We're going to take the square root of 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine of 75 degrees. Whoop, wait a minute. The cosine, got it, of 75 degrees. So 840 squared, 750 squared, 2 times 840 times 750 cosine 75 is about 971 miles apart. So the distance is about 970.56. So they gave us words. We can answer in words. The two planes are about 971 miles apart after 2 hours in flight, provided that they stay on that same bearing, right? And then our last couple of examples, we're going to look at Heron's formula. This is the formula for how to find the area of a side-side-side triangle. So we're going to take half the perimeter, and whatever that answer is, we're going to multiply that half perimeter times the difference between the half perimeter and each side, and then take the square root of that to give the area. So we have a triangle with the sides of 7 meters, 16 meters, and 18 meters. We need to find out what half of the perimeter is. So 7 plus 16 plus 18, that's 41. And half of 41 is 20 and a half. So if you take 20 and a half minus 7, you get 13 and a half. 20 and a half minus 16, and you get 4 and a half. And then 20 and a half minus 18, you have 2 and a half. So the area of the triangle is the half perimeter times 13 and a half times 4 and a half times 2 and a half under the radical. Let's see what that looks like. We want it to the nearest square meter. So we got the square root of 20 and a half times 13 and a half times 4 and a half times 2 and a half. So about 56 square meters. since the area is approximately 55.798 square meters and they want the nearest square meter, we would round up to about 56 square meters for our answer. And then our last example, we have a 120-foot tower, and that tower is leaning over. So we got a 120-foot tower, and that tower's leaning over 120 feet. There's a guy wire that's been anchored 82 feet from the base of the tower. So if this is the base of the tower, and we go out here 82 feet, they put a peg in the ground and they attached a guy wire to it, and that guy wire is a support to hold the tower up. It's 160 feet in length, and it's 82 feet away from this. So if we call this angle B, this is the ground, we want to know how far from vertical the tower is leaning. So that would look like, this. How far from vertical? So that would be this, right? So first we want to find the cosine of angle B. Calling this A, B, C. So this is little a, this is little c, this is little b. So we got 120 squared and 82 squared, because this is a side angle side, minus 160 squared divided by 2 times 120 times 82. So working this math on our calculator, we're going to find out that angle B is cosine inverse, and I get negative 4476 on the numerator and 19,680 on my denominator. And then going to our calculator, I'm going to have to convert this answer to degree from radian. So let's think about this. We got cosine, oh geez, pushing the wrong button. Cosine inverse of negative 4476 divided by 19,680, and that's 1.800, so we want to multiply that by 180 over pi to convert to a degree. So we got 103.15 degrees. So this is 1.80024 times 180 over pi gives us 103.15 degrees. And we want to know how far off vertical it is. So I'm thinking about vertical here. If this is 103, how far off vertical is that leaning? So we got 103.15, and subtracting it off 90 degrees means it's leaning 13.15 degrees from vertical, because it's tilted over. Instead of being upright at 90 degrees where the tower, the red, should be, it's leaned another 13 degrees off of that, and now it's leaning at 103.15. And that finishes up Lesson 6 in Unit 5, Law of Cosines. I'll see you next time.